In question 3, we are given that fx equals 2 ln x minus 3 for x is greater than 3, and we are asked in part A to find the asymptote. So we could just plot this in our calculator and look at it visually by inspection, or alternatively we should be familiar with the graph of ln x, which would be something like this, passing through the point 1, 0 with an asymptote down here of x equals 0. So given that here we've got a horizontal translation 3 to the right and a stretch which won't affect the asymptote, it's just going to be this translated x equals 0 translated 3 into the right, which is going to give us x equals 3. In part B, we are asked to solve 2 ln x minus 3 is equal to 0. So for this, you could solve it graphically on the GDC, or alternatively, if you wanted to work it out, then you would say that ln x minus 3 is going to equal 0, dividing 3 by 2, and therefore x minus 3 is going to equal e to the power 0, which is going to equal to 1, so therefore x equals 4. In part C, we are asked to find the region enclosed by the graph of f, the x-axis, which is here, and the line x equals 10. And it is rotated 360 degrees about the x-axis. So find the volume of the solid formed. So it should be fairly straightforward to recognize that this is a question about volume of revolution. So we know that this point here from part B, we found that the x-intercept was at the value x equals 4. So we've got here the lower bound and the upper bound, if you want to think of it like that. So we need to integrate. So this would be the general formula that we're looking at. So I'm going to integrate that with respect to the x. So in this instance, it's going to be pi multiplied by the integral between our two bounds of 10 and 4 of our function, which is 2 ln x minus 3, all squared with respect to x. And if you put that into your GDC, you get 141.538, which we will take approximately as 142 units cubed, because it is a volume.